I'm pleased to introduce Mark and Rachel from the Esri Inc. development team. So they work on the runtime technologies that power our native applications on desktop and mobile. So Mark is the product owner for the ArcGIS Runtime API for Java, and Rachel is a software engineer and developer advocate for the ArcGIS Runtime team. So I'm pleased to introduce them both, and they're going to talk to you about all things runtime. So over to you guys.
So in this session, we're going to be looking at options where the end game is you'll have an application for viewing and collecting data. So all the technology we're going to be talking about here is based on our ArcGIS Runtime family of products. I'm going to be taking you through some of the options where you can actually get an application. So the easiest way of doing this is to use one of our ready-made applications, which are actually built with ArcGIS Runtime. But if you want to have a little bit of extra configurability in that, then we have application builders. But what we're really about in this session is writing your own application. So cutting some code, which will give you the most flexibility in the end result that you come up with for a fully configured application. We'll be taking you through a run-through of some of the functionality we have in Runtime so you can get a feel for what you can actually achieve with this. We'll talk about licensing and deployment of your application. So once you've written your app, you can get it ready for market or for use in your organization. And then we'll finish off by taking a look at some new developer APIs we've added to the Runtime family, where we've been integrating game engines so you can bring GIS data into game engine technology. Let's just start off by just setting the scene about what ArcGIS Runtime is. So my pitch here is that it's a set of modern SDKs for allowing you to bring in mapping and GIS functionality into your own applications. So this can be a client to the ArcGIS platform, but you don't necessarily have to be bought into that Esri technology to use Runtime, because we support all sorts of formats of data, including OGC data, for example. So what we're about here is applications that natively run on your device. So these are not applications that run inside a web browser. And the ArcGIS Runtime family of products can be deployed to both mobile and desktop platforms, so Android and iOS, and then the operating systems we support are Mac, Linux, and Windows. Now these are made available through a number of different APIs, very much usually depending on the platform you're deploying to. So we have dedicated APIs for Android and iOS. We have the Java API, which is for writing cross-platform desktop applications. And we've got .NET, which incorporates Xamarin and Qt, which is for quite a wide variety of cross-platform mobile and desktop deployments. And it's worth reiterating that we use these APIs in our own products too. Now, those of you who were in the previous session may be thinking, well, we've just had a really good demonstration of the JavaScript API, and I will acknowledge this is a fantastic technology. And actually, it's functionally equivalent to most of Runtime. And arguably, the skills for writing a web application requires less specialist development skills. So why would you use Runtime? Well, you could actually write yourself a fantastic application, mobile application for doing, I don't know, ecological data collection, for example. And then you drive for a few hours up into the Highlands of Scotland to perform your plant survey. And when you get there, there's no network connection. So that's going to be a disappointing experience. So what Runtime gives you is the ability to be able to bring a copy of your enterprise data onto your device so that you can view and you can also edit that data. So when you're back in an environment, when you have network connectivity at the end of the day, you can synchronize your changes back up to your enterprise environment. Of course, Runtime is very good if you want to integrate with the device hardware, so cameras, GPS, compasses, accelerometers, gyroscopes, all of those things. It's much better to write a Runtime native application if you want to integrate with this hardware. So this is something which I can talk about for some hours, but we need to restrict that into a fairly short session here. So what we're really about is viewing and editing data, GIS data. So that can be visualized in 2D maps or 3D scenes. And then on top of that, you can add in other geospatial analysis like routing with road networks, for example, geocoding, which is your address location, and then quite a lot of spatial analysis you can perform on top of that. So that may be industry-specific things like performing a utility network trace. It could be 3D-specific things like looking at line of sight or viewshed calculations or 3D measurements. There are lots more, but we'll take a look at some of those. And in terms of the data you can work with in runtime, this can come from server or file-based technologies. We cover a large range of formats. So let's just start off by looking at a way of being able to collect data with an app without actually writing any code. So we have a number of applications that we've written using the ArcGIS Runtime product, which you can just download and run on your iPhone or your Android device. Now, these have been designed to support common data and field operation workflows, and they're free to use alongside the ArcGIS Online platform. So if you're already a subscriber to this platform, you can just download and use these applications. And they're designed to work together in specific workflows. So examples of these applications include the Navigator application, which, as its name suggests, is to help you route to sites that you want to perform surveys on. And then we've got data collection apps, probably the most comprehensive of which is the Field Maps application. And then we've got lighter weight data collection applications like Survey 123 or Quick Capture. So they're worth a try. They may do what you want them to do without having to go any further. The next stage of configurability that you can build upon is looking at one of our application builder technologies. So in the world of runtime, we have a product called AppStudio. And it's kind of a low or no code option for creating desktop or mobile applications. And there's a set of templates to quickly go about making your applications. So you can do things like personalize those applications with your own company logo on, for example. And again, this technology is built using ArcGIS Runtime, so our Qt API. And the typical workflow you would go through if you're working with the app builder application is you'd select one of the templates. There's a wide range of them for different data collection workflows. You can do a bit of configuration. There's a little bit of custom behavior you can add in that using the QML markup language from Qt, test, and then deploy. Now, in terms of deploying the AppStudio options, there's a couple of choices. You can use a product of ours called the AppStudio Player, or you can actually compile it into an application that you can upload into one of the app stores. Probably the easiest way of doing this is to use the AppStudio Player. So this works well for enterprise-style deployment. So you just log into your enterprise and the app configuration is brought into your app for you. So they deploy themselves effectively. But if you want to go down the route of compiling your app into a sort of a traditional installer, that's an option which is available with the developer edition of AppStudio. And there are different building methods, so you can have all of the different platforms to deploy it yourself, or you can use cloud make options as well, which then you can deploy to the App Store to distribute your applications using a traditional setup program. So what we're really about here is writing code using the Runtime product. So what we're going to do now is give you an introduction to how you can get going with ArcGIS Runtime. And for that, I'm going to hand you over to Rachel.
Great. Thanks, Mark. So yeah, for this next part of the session, as Mark said, we'll be walking through the landing pages for how to get started with developing using ArcGIS Runtime before going in and taking a quick look at a demo application where we'll see some real code. So if we just switch over to my laptop now, we can find ourselves back on the developer's documentation page that if you're at the previous session, Richard talked us over some of the other options available here. All of the Esri developer technologies are available on this landing page, and you can find all of the APIs that Esri has to offer here. So that's from the JavaScript web APIs, all the way through to our game engine SDKs, and of course the main part of our presentation, the runtime APIs. These are available both as mobile APIs and also for native and desktop. And we cover 5 APIs here, that for Android, iOS, .NET, Qt, and Java. Since we don't have a lot of time today, we won't be able to go into all 5 of these SDKs. So instead, we'll be focusing on the Runtime API for iOS, and we'll be taking this iOS theme throughout the rest of the presentation. So let's take a quick look at what resources are available for getting you started with developing for Runtime using iOS. On the left side of the page, you'll find the navigation bar, which has a huge range of documentation from how to get started, how to install Runtime onto your machine or device, as well as a whole lot of conceptual-based topics for how to implement GIS into your geospatial applications. Probably one of the best places I would recommend to get started if you're new to developing, or if you're interested in developing, or have colleagues within your organization who would like to use our developer technologies, is to head over to the tutorials page. And for example, if we have a look at tutorials that are available for search and location, we can take a quick look at this display device location tutorial. Our tutorials will walk you through the basics of how to open an Xcode project to use Swift to develop an iOS application. We'll show you code, and we'll show you how to run the application from that Xcode application so that you can display the location of your device on your screen there. There are also downloadable solutions available, so if you're comfortable that you know this is the technology that you want to have in your application, then you can download the solution and begin developing immediately from that without having to type through any code, if that is the way that you prefer to learn. So to complement this extensive documentation that we have, walkthrough tutorials are available, as I've said, but in the same way that JavaScript had, we also have a huge library of sample code available to us. So if I just navigate to the top here, and we can take a look through some sample code, we have over 200 samples available for bite-sized pieces of our API functionality. So if you were curious to know, how would I go about displaying a root layer within my iOS runtime application, you can navigate through the pages here, find the display root layer, and go straight to the sample code, which is available here, and it's really easy just to copy this code over into your application if you wish. We have some handy widgets available to take that code immediately to your own developer workspace. As well as the sample code available on our website, we of course have many GitHub repositories. So every runtime product that we will talk about today, those 5 runtime products for iOS, Android, Qt, .NET, and Java, they all have individual GitHub repositories for samples. This is the iOS samples repository. So you can go in, you can pull this down onto your own machine, and you can get running with an application immediately if you're familiar with version control and GitHub. So back to our documentation pages, just very quickly to cover some additional items that may be of use to you as you embark upon your developer journey or continue along with it. For those inevitable moments that we all have where we get stuck and things just don't work as we want them to, we have numerous supports available for you. So these can be found by navigating up into the support bar up at the top here, where you have access to our Esri community, which has subsections, subforums for our ArcGIS runtime technologies. And these include a space to ask questions to the experts to help you get over any problems that you have, ideas to launch any features that you would like to see, and also blogs that Esri colleagues will write to help you solve your problems. So before moving on to showing you a demo and some code, there's one final important key to, literally a key to be able to continue on your development journey. And that key is that of an API key. So an API key is required if you are developing an application using ArcGIS Runtime, which requires access to Esri's base maps or location services and premium content. It's very easy to get set up with one of these. You would sign into your developer's account or perhaps create a new account if you don't have one already, and you can create a new API key and handle that within your dashboard within ArcGIS Online here. It's worth noting that if you are using your own hosted data, then you wouldn't need an API key to be able to develop and put that into your application. Okay, so if we switch back to Mark's computer now, we will just take a quick look at the intro slide for what's coming up next. So hopefully that's given you a taste for when you want to get started on your developer journey. You've got those get started guides. But for the next part of this demonstration, I'm going to step through a really simple code example that will show you how to write an iPhone application using Swift that shows a pre-configured web map. And I'll demonstrate this again using the ArcGIS Runtime for iOS using Xcode. So if we just switch back to my machine, then I will open up Xcode. And actually, before I jump into Xcode, I am going to very quickly show you the data that we are going to be putting into our application. So let's open up a web map. So we're in ArcGIS Online here. And what I've done is I've used ArcGIS Pro to create and edit a series of mountain data. In this case, Munros, which are mountains over 914 meters in height, or 3,000 feet in Scotland. I've taken those Munro peaks, the locations for those as point data, and I've clipped them to within the confines and extents of Scotland's 2 national parks here. So just for a quick walkthrough of the data, we have the national park available to see there, for the Cairngorms. We have our peaks representing the mountaintops, and we also have some symbology applied to them via size and a color, and a scale-based rule for, as you zoom in, the labels representing the name and the height of the mountain will render. So we want to get this web map into our iPhone application now. How do we do that? The most important thing at this point of the web map ArcGIS Online part to keep in mind is looking at the URL for this web map. So this item ID here is unique to this web map and will allow us to reference this using Runtime Code. So I'll try and remember this E382 as an easy to remember 4-digit reference at the end of this ID to reference back into Xcode. Okay, so finally some code that some of you might have been waiting for a while. Here we are within Xcode, and I am just going to talk you through some really basic runtime code here. First of all, I'm in the main view controller class within Xcode, and probably the most important thing that you can do when starting developing with Runtime is importing ArcGIS. This allows you access to all of the Runtime API classes within the following code. Next, one of the main classes really across all of our Runtime SDKs that underpins a lot of the applications is this map view class. So the map view really defines the UI component of your application. It allows you to interact with data and allows you to handle user interactions such as clicks or taps or pans. We also want to reiterate or to focus you towards a map class here as well. So we have this map view, which is the UI component, and what sits in the map view is an AGS map, ArcGIS map. And the map is the part that holds all of the data that you wish to put into your application, be that feature layers, base maps, data, or what I'm showing you today, a web map. So to configure the web map, we are just stepping back into the code here, where we define a portal in code. So we create a portal of type ArcGIS Online, since this is where our web map is hosted. And then if we remember that E382 unique item identifier from that web map, we store that as a string and use Runtime to create an ArcGIS portal item from ArcGIS Online type of portal with the item ID. And we then pass that into the map, ArcGIS map here, before finally assigning the map onto the map view. So we've got that map view UI controller, which will host the map, and then we have the map, which contains the web map data. So if I just switch over now to the iPhone view itself, we can take a look at that in situ. So here I have an iPhone application, which in a relatively few lines of code, I've been able to bring in as an application on my device. If I zoom in, you'll see exactly the same features as what we had in the web map. We have the symbols for the Monroe Peaks, and if we just keep in zooming really steadily, we should see those scales, those labels appearing, telling us that we have our Ben McDewey North Top at 1,295 meters high. So this is really cool because this means that I have a really simple application that I can just take out with me on my next trip to the Cairngorms. And if I want a handy reference to what Monroe Peaks are there within the Cairngorm National Park, I can pull out my iPhone, have a look at this application, and see what's available. A natural extension to this would be to add in my device location so that I can see where I am in relation to the Monroes. And you could also bring in other data, such as perhaps routing information or directions, so that I could find my way to the car park start point to begin walking in some of these Monroes. So just to summarize what we've looked at here, we've used Xcode and ArcGIS Runtime to develop a very small bite-sized iPhone application which displays a web map authored from ArcGIS Pro and available as a web map on ArcGIS Online. We've covered the concept of using a map view class, the UI component, and a map class which hosts the data and displaying that on an application. I'm going to pause there and remain on the iPhone view and just give you a very quick tour through some of our sample offerings. So every one of our ArcGIS Runtime APIs has a sample viewer ready to download or install on your device and browse through our samples. So we have on the iOS a whole range of categories. And just to save some time for today, I'm not going to go into every single one of them because that would just be overloading. But instead, I have some favorites set up ready to show you. So I've talked so much about device location that it would be rude of me not to show you that. So if I just navigate through this application, turn on location, and then tap on compass navigation, we have an application here showing where we are in the Joan Knight studio across the road from the Perth Concert Hall there. And as I turn the device, the compass navigation also reacts to that, so that's a really nice feature. If I tap back out and show you another example, again, this uses device location. Here, this sample will show you how to set up location-driven geo-triggers And this app will set up a notification for you when you have entered or exited a particular area. So this sample mimics somebody walking through a zoo where they are currently in the desert area, and as they walk along this boundary here into the meadow, you'll see notifications coming up at the top showing areas of interest that they are walking past, and when they've entered and exited some of those areas. We don't only, of course, have functionality for 2D maps, we also have huge functionality available for 3D applications. So in this example here, we have a 3D model of an aircraft, which is taking a flight through the Grand Canyon. Not Grand Canyon, I'm not entirely sure where this one is actually. I think that Mark developed this one, but it is the Grand Canyon. Yes. So yeah, this I think is one of our favourite demo ones to show, and is quite a lot of fun to watch that model tilt. And that's all using the ArcGIS Runtime technologies, which, as I've mentioned before, you can use across other platforms. Okay, so if we switch back over now to Mark's machine, we'll just briefly take a look at what offline editing workflows are available to you. So say you are wanting to take your device, like your iPhone, out into the field, and you don't have any connectivity, then this is where Runtime really comes into its own without needing that data connection. There are a couple of ways that we support this. So for the single user workflow, this would be an example from you've got your data ready in ArcGIS Pro. That could be a mobile map package or a mobile geodatabase perhaps. Then you would just sideload that onto your application and access that in the field ready to go. However, a more common workflow is when you have multiple users within your organization whose data is hosted on ArcGIS Online or the portal, and map packages are stored on the server. When you're out in the field, you'll be editing your data, and then you want to come back and sync that back up, and then the next day take that data from the server back into the field as you go. So we have two recommended workflows here to work with. The first would be on demand, and that would be if your organization has low volumes of users who, when they're ready, they can define an area of data to download from the server on the fly, make a request, and then the server will download that data onto the device for you. However, the server won't scale to hundreds of users, so if hundreds of users are requesting the same data from that server over and over, then that could induce quite a lot of load in the server and might not give optimal results. So in this example, we would recommend using the pre-planned workflow. And this is where the server has map packages already uploaded, ready for download, and it removes the need for any server load. So if we switch one last time back to the iPhone, I have a sample application ready to go. If we just switch over to the iPhone when we can. There we go, thank you. So this is the download pre-planned map sample where we have an online web map with some data hosted on top in Naperville. So I want to take this application, I want to have a look at some of the data in this area without any connectivity. So I want to download a series of pre-planned map areas that my server admin has prepared in advance for me. So for example, if I tap on the City Hall area, I can see that that area is downloading and is now saved locally on my device as a standalone data source for me to be able to take out and use in the field. Okay, so here, just to summarize, we've taken a look at some offline editing workflows. And the key thing to take away from this is that this pre-planned map workflow will scale better with hundreds of users, And if you have more tens of users in your organization, then we'd recommend that on-demand workflow, which we also have samples for. I'll pass back to Mark now on his machine to cover licensing options.
Thanks, Rachel. So some good demonstrations there, hopefully giving you an idea of a lot of the capabilities in runtime, most importantly the offline workflows. So you've put some effort now into writing an application and you're ready to make it go to market or to use that in your organization. What you need to do is to license your application, and Runtime has got 4 levels of licensing. So starting off with light, which is a free to deploy license, and there's increasing levels of cost and functionality associated with basic, standard and advanced. If you click on that web page we've got there, there's a matrix which sort of explains what the different levels of functionality are. But just to give you a feel for what you can do for free with the light license, this is really well suited to, say, a citizen science data collection application. So if you've got some data published on ArcGIS Online that is not locked down, there's no security behind it, you can use a light license to send members of the public out to collect sightings of birds that they've spotted in their garden, for example. So those are the licensing levels, but technically there are 2 ways of licensing your application. Now, probably the easiest to understand is what we call the named user licensing model. So if you're already a subscriber to an organization in ArcGIS Online, or you've got your own internal portal, there's no extra cost associated with using Runtime. All you have to do is programmatically log into the portal, and then that will license your application. Now that works with the offline workflows as well. So when you license your application, it does that for a period of 30 days. So as long as your offline application can reconnect to the portal or ArcGIS Online within that 30-day period, that's a good workflow to go with. Now it may be that you're not using the Esri systems, so you're just using your own data formats or OGC data. Well, if that's the case, then you need to license it by burning a license key into your application, and these are available to purchase in license packs that you'll put into your app. So moving on to a new area of development that we've been working on for a number of years, I want to introduce a couple of new products that we've been working on. So this is where we've been bringing GIS data into game engines. Now, I'm going to be talking about this in a little bit more detail in the closing plenary later on this afternoon, but I just wanted to look at this more from a sort of a developer point of view. So we've got 2 new products. So we've got the Maps API for Unity and the Maps API for Unreal Engine. And this is something which really gives us what I believe to be the next generation of 3D GIS. So game engines are a technology which works with, I've just forgotten what to say then. It works with consumer technology, so you can use augmented reality on your mobile phone or virtual reality headsets, and you're bringing your data into a sort of a premium rendering experience. So this isn't just for the traditional flat screen technologies like the projector screen behind me, but you can also write extended reality applications which include virtual, augmented or potentially mixed reality as well. The game engines are a good technology to work with because you've got extra libraries to give you access to physics engines, animation or special effects. So we can do that thing where you can show your data when you've got a rainy day, for example. I've seen quite a lot of that going on today already, so we're doing it too in Runtime with the game engines. And they're also there for writing cross-platform applications, so you can deploy these apps to either sort of mobile or desktop technologies. So what I'll do is I'll quickly move over to a project that I've started to put together in Unity. Now this is a developer technology, and everything that you can achieve, you can write code for. But what I'm doing here to show you that this is actually quite an approachable technology is I'm using Unity's component view to put together a 3D experience. So to make this easier, what we've done is the plugin that we've created for Unity has got a map creator window, which we can then define the the experience that we're working with here. So I'm going to start off by defining the map area and the camera view that's looking down onto the data that we're working with. And then we can build that up with the GIS data that we're all familiar with, like a base map or elevation or layer information. So here we have some building information that I'm looking at in Unity. And then using the game engine technology, I can continue to build up an application which has got sort of first-person views of the data. Now, the story for Unity is very similar for Unreal Engine. So in Unreal Engine, again, you can write everything in code in C++, but we also support configuration using Unreal Engine's blueprints. So you can see it's an approachable technology to use even if you're not a hardcore developer. So with that, I'll bring our session to an end, and hopefully that's given you an idea for some of the things you can do using the native application development options we have. So this is ArcGIS Runtime, and then there's our two new products, the Maps SDKs for Unity and Unreal Engine. So with that, do we have any questions?
Thank you, Mark. Thank you, Rachel.